A fabric that hears your heart. Having trouble hearing? Just turn up your shirt. That's the idea behind a new acoustic fabric developed by engineers at MIT and collaborators at Rhode Island School of Design. The team has designed a fabric that works like a microphone, converting sound first into mechanical vibrations, then into electrical signals, similar to how our ears hear. Welcome to Science Unmasked. Please subscribe and turn on the notification button so you can get our latest videos. All fabric vibrate in response to audible sound, though these vibrations are on the scale of nanometers, far too small to ordinarily be sensed. To capture these imperceptible signals, the researchers create a flexible fiber that, when woven into a fabric, bends with it like seaweed on the ocean's surface. The fiber is designed from a piezoelectric material that produces an electrical signal when bent or mechanically deformed, providing a means for the fabric to convert sound vibrations into electrical signals. The fabric can capture sounds ranging in decibel from a quiet library to heavy road traffic, and determine the precise direction of sudden sound like hand claps. When woven into a shirt's lining, the fabric can detect a wearer's subtle heartbeat features. The fibers can also be made to generate sounds, such as a recording of a spoken word that another fabric can detect. Lead author Wei Yan, who helped develop the fiber as an MIT postdoc, sees many uses for fabrics that hear. When wearing an acoustic garment, someone can talk through it to answer phone calls and communicate with others. In addition, this fabric can imperceptibly interface with the human skin, enabling wearers to monitor their heart and respiratory condition. Sound layering. Fabrics are traditionally used to dampen or reduce sound. Examples include soundproofing in concert halls and carpeting in our living spaces. However, the researchers have worked for years to refashion fabric's conventional roles. They're focused on extending properties and materials to make them more functional. In looking for ways to make sound-sensing fabrics, the team took inspiration from the human ear. Audible sound travels through the air as slight pressure waves. When these waves reach our ears, the tympanic membrane or eardrum uses a circular layer of fibers to translate the pressure waves into mechanical vibrations. These vibrations travel through small bones into the inner ear, where the cochlea converts the waves into electrical signals that are sensed and processed by the brain. Inspired by the human auditory system, the team sought to create a fabric ear that would be soft, durable, comfortable, and able to detect sound. Their research led to two important discoveries. Such a fabric would have to incorporate stiff fibers to effectively convert sound waves into vibrations. At the same time, the team would have to design a fiber that would bend with the fabric and produce an electrical output in the process. With these guidelines in mind, the team developed a layer block of materials called a preform, made from a piezoelectric layer as well as an ingredient to enhance the material's vibration in response to sound waves. The resulting preform, about the size of a thick marker, was then heated and pulled like taffy into thin 40-meter-long fibers. Lightweight listening. The researchers tested the fiber's sensitivity to sound by attaching it to a suspended sheet of mylar. They used a laser to measure the vibration of the sheet and, by extension, the fiber, in response to sound played through a nearby speaker. The sound varied in decibel strength between a quiet library and a heavy road traffic. In response, the fiber vibrated and generated an electric current proportional to the sound played. The performance of the fiber on the membrane is comparable to a handheld microphone. Next, the team wove the fiber with conventional yarn to produce panels of drapable, machine-washable fabric. One of the researchers said it feels almost like a lightweight jacket, lighter than denim but heavier than a dress shirt. The fabric was able to detect the angle of the sound to within 1 degree at a distance of 3 meters away. The researchers envisioned that a directional sound sensing fabric could help those with hearing loss to tune in to a speaker amidst noisy surroundings. The team also stitched a single fiber to a shirt's inner lining just over the chest region and found it accurately detected the heartbeat of a healthy volunteer, along with subtle vibrations in the heart's S1 and S2 or lub-dub features. In addition to monitoring one's own heartbeat, scientists see possibilities incorporating the acoustic fabric into maternity wear to help monitor a baby's fetal heartbeat. Finally, the researchers reversed the fiber's function to serve not as a sound detector, but as a speaker. They recorded a string of spoken words and fed the recording to the fiber in the form of an applied voltage. The fiber converted the electrical signals to audible vibrations, which a second fiber was able to detect. So in addition to acting as wearable hearing aids, communication devices, and clothing that track vital signs, the team sees applications beyond clothing. They believe it can be integrated with spacecraft skin to listen to accumulating space dust, or embedded into buildings to detect crack or strains. It can even be woven into a smart net to monitor fish in the ocean. This fiber that can hear has suddenly opened us up to a whole new world. That's all from Science Unmasked. Remember to subscribe and like our videos and share it with your friends.